If you've ever looked at a rational function and wondered where the graph is going, asymptotes give you the answer instantly. Let me show you the fast method. But first, what is an asymptote? An asymptote is a line that a graph gets closer and closer to, but never touches. Understanding asymptotes is crucial for analyzing rational functions and their behavior. Vertical asymptotes occur where the denominator equals 0. Horizontal asymptotes are lines that the function's graph approaches as x goes to plus or negative infinity. Slant asymptotes occur when the numerator degree is exactly one more than the denominator degree. We'll explore all three types and learn how to find them quickly and easily. Vertical asymptotes occur where the denominator equals 0 and the factor does not cancel with the numerator. So in order to find those, you'll need to factor both top and bottom, cancel common factors, and find remaining zeros if any. Let's see this example. Given the function f of x equals 3 over x squared minus 9, we want to find the vertical asymptotes. So in this case, we'll only need to factor the denominator because the numerator is the constant 3. So x squared minus 9 can be factored as x minus 3 times x plus 3. So obviously no cancellation occurs. We will set the denominator to be equal to 0 and solve for x. So if we let our first factor, x minus 3, to be equal to 0, in order to solve for x, we'll add 3 on both sides. Therefore, x equals 3. Doing the same for our second factor, x plus 3, if we set it to be equal to 0, in order to solve for x, we'll subtract 3 from both sides. Therefore, x equals negative 3. So we have two vertical asymptotes here, x equals 3 and x equals negative 3. Looking at the graph, you can see that the function's graph gets closer and closer to negative 3 and positive 3, but never actually touches it. Horizontal asymptotes describe the end behavior of a function as x approaches positive or negative infinity. So we'll use degree rules in order to find them quickly. If we let n be the degree of the numerator and m be the degree of the denominator, we can use these rules. First, if n is less than m, we'll have a horizontal asymptote at y equals 0. If n is equal to m, the asymptote will occur at y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. And finally, if n is greater than m, there are no horizontal asymptotes, although there might be an oblique or slant asymptote. So let's look at this example. F of x is equal to 4x plus 1 over x minus 5. In order to find horizontal asymptotes, we must compare the degree of the numerator to the degree of the denominator. So in this case, the numerator is a function of degree 1, that is 4x plus 1, and the denominator is also a function of degree 1. So since the degrees are the same, the horizontal asymptote is the ratio of the leading coefficient. Y will be equal to the leading coefficient of the numerator, which is 4, over the leading coefficient of the denominator, which is simply 1. So 4 over 1 is 4. Therefore, I have a horizontal asymptote at y equals 4. We can see it right here. The graph gets close to y equals 4, but never touches it. In order to find the vertical asymptote, first we must cancel any common factors. In this case, we don't have any. So we can simply set the denominator to be equal to 0. That is x minus 5 equals 0. And in order to solve for x, we'll add 5 on both sides. Therefore, x is equal to 5. And we have a vertical asymptote right here at x equals 5. Now let's discuss slant or oblique asymptotes. These occur when the degree of the numerator is exactly one more than the degree of the denominator. In order to find the equation of a slant asymptote, we'll need to divide the numerator by the denominator using long division or synthetic division and extract the quotient. That is, the quotient without the remainder is the slant asymptote equation. Looking at this example, f of x equals x squared plus 3x plus 1 divided by x minus 2. The degree of the numerator is 2, that is a quadratic equation, and the degree of the denominator is 1. Therefore, I know that I will have a slant asymptote. So I'll need to divide the numerator by the denominator, that is x squared plus 3x plus 1 divided by x minus 2 is equal to x plus 5 plus the remainder of 11 over x minus 2. So in this case, the quotient is x plus 5. We ignore the remainder. So I have a slant asymptote y equals x plus 5. It's its equation. So if we look at the graph here, we can see that the graph gets closer and closer to that line but never touches it, and that line is y equals x plus 5. In order to find a vertical asymptote, we'll need to factor both numerator and denominator and cancel any common factors. There aren't any in this case, so simply we can let the denominator be equal to 0 and solve for x. So if x equals 2, our denominator will be 0. Therefore, there is a vertical asymptote at x equals 2, and we can see it here on the graph. Here's a quick reference summary. In order to find the vertical asymptotes, set the denominator to be equal to 0 after canceling common factors between numerator and denominator and solve for the variable. In order to find horizontal asymptotes, you'll compare the degrees of the numerator and the denominator. And in order to find slant asymptotes, if the degree of the numerator is exactly one more than the denominator, you'll divide numerator by denominator in order to find the equation of the slant asymptote. Here's your challenge. Find all asymptotes for the following function. F of x equals 2x squared minus 3x plus 1 over x minus 4. First, in order to find vertical asymptotes, remember to check if any factors cancel. Compare the degrees of the numerator and the denominator in order to find if there's a horizontal or slant asymptote. And please drop your answer in the comments. Now you can confidently find vertical, horizontal, and slant asymptotes for any rational function. You know the rules that make asymptotes easy to identify. Thanks for watching. Like, subscribe, and don't forget, math success starts when you stay on the fast track.